ions exist after making it? Oh, I love this question. Okay, so Leon Meyer is asking, like, which came first, the chicken or the egg? Okay, this is how the periodic table was devised. And I will say that a lot of people were involved. There were a lot of different ideas of how the elements should be organized over the years. But ultimately, the periodic table that we see and we use today, almost always, is based on the following. Okay, so one of the first things that happened was actually just looking at mass and realizing that lithium is about 7 grams per mole, beryllium is about 9 grams per mole, boron is 10 grams per mole, carbon is 12. So they were put just in order of increasing mass. All right, so that was one of the ways that they were organized. But that would just be a long list going, and just kind of in one direction, right? And here's where there was a bit of a glitch where that didn't work. Okay, so look at what happens here with iron. The mass is 55.8. And then we go to cobalt, and the mass is 58.9. So it's just increased. That's normal, what we would expect. But then you go to nickel, and it's 58.6. That is a smaller mass than cobalt. So originally, these two elements were inverted. Scientists thought that nickel was smaller than cobalt because it had a smaller mass. All right, so it wasn't until a lot more studies were done to figure out atomic number, and this is the number of protons that are there, and then they could put them in order of increasing number of protons. Okay, so there's that. There's lining them up in these rows like that according to increasing protons. But the thing that makes the periodic table especially unique is that it is also very specifically lined up in these groups in this way. And the way that this was devised was by reactivity. So they realized that there were a lot of different metals, and so they began to study these different metals. And there was a certain type of metal that was much more reactive than the others. And eventually they grouped these together because they behaved so similarly. And those were the most reactive metals are the alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. So these metals, they then decided, and this was mostly Dmitry Mendeleev, and Meyer was his last name. I do not remember his first name. So Mendeleev and Meyer came up with this format where the elements that had very similar chemistry, they reacted similarly, they were then put into these columns, and they called these groups. And then there were other types of metals that also behaved similarly, different from the group 1 metals, but they reacted similarly to each other. And so once again, they put these in the same group where we have beryllium, magnesium, calcium, strontium, barium, and radium. And it was very interesting because it was then realized that by the time they got to the end of, in this case, in period 2, there were 8 other elements. And then they went back to the beginning to make sure the group 1 similarly reactive elements were lined up, and then the next element, similarly reactive with group 2, they realized that there was this pattern happening. And so this was very exciting at this point. So let me go back to your question. Did they make the periodic table by the periodic trends? Yes. In many, I want to say that they weren't looking at all the periodic trends, but they were looking at some of them. And some of those periodic trends were the reactivity. And so they lined up and created this exact format based on those periodic trends. Now, the second part of your question, or the second, you gave two possibilities. They made the periodic table based on trends, yes. But you know what's cool? Is that I can also answer yes to the second possibility you gave, because you said, or did they realize that periodic trends exist after making it? Well, after they put it together and did line everything up in the ways that are shown here, they realized that there were other periodic trends that followed this format. So there are periodic trends that they didn't even have the means or the instruments available or the technology available to even study those trends yet. Like atomic radius, back in the 1800s, there was not a way to determine atomic radius. So they put together the periodic table based on reactivity, and then it turns out that there are trends with atomic radius based on the periodic table. And everything is consistent, which is fabulous. Another really cool thing oh my gosh, yes, they did so many because we're talking about lots of different scientists, so it wasn't just one scientist doing all the work. Lots of different scientists were doing it, and they were looking at each other's data, and they were working for many, many years on it. So yes, lots of trials. Absolutely. One really cool thing they did, and I really appreciate this story a lot, and it was Mendeleev who was the first person who did this. Dmitry Mendeleev was from the area that I believe is now Russia. Okay, and what he did is he realized that aluminum had some, certain properties, and he was lining up all the known elements. Okay, and then he went back to lining things up again, making sure potassium was below sodium, and calcium had been discovered, and then he realized that if he wanted to keep everything lined up and make sure bromine was below chlorine, was below fluorine, because all of these halides were behaving similarly, so he wanted to keep those there. But there was no element that was right below aluminum. He had to create a blank spot here. Gallium had not been discovered. So what Mendeleev proposed was that there is an element here. It was an unknown, and so he called it Eka aluminum. And I don't know what Eka means. Maybe it's a Greek word that means similar to or something like that. But that was his point, is he proposed that there was an element that had not yet been discovered that would have similar properties to aluminum. He did the same with germanium. Germanium had not yet been discovered, and he proposed, once again, there's an element, and he called it Eka silicon, and that went there. And indeed, these two elements were, I keep wanting to say invented. They were not invented, discovered. These two elements were discovered, and they were very close to the proposed properties that were expected by Mendeleev, both of these. So, very, very cool. I believe tin had been discovered at that point. So there was a gap between silicon, tin, lead. There's like this empty hole. They were like, I bet something's there. And they were right. So how this was all constructed was just brilliant. And like I said, it's still used today. And I think one of my favorite parts also is that it turns out that it is also in alignment and fully consistent with quantum theory and with orbitals and with electron configurations in the orbitals and all of that beautiful stuff that wasn't figured out until the early 20th century. Like the early 1900s. That it all fits together. It all fits together beautifully. So very, very cool.